Hello friends, I am from Physics faculty of QLS Academy. Today we are going to learn about sound. I hope you will enjoy learning about sound. So let's get started with our today's lesson. Now first topic is sound waves are longitudinal waves. In previous lesson it was already mentioned that sound is a mechanical wave that is created by a vibrating object. The vibrations of the objects set particles in the surrounding medium in vibrational motion, thus transporting energy through the medium. For a sound wave travelling through the air, the vibrations of the particles are best described as longitudinal. Longitudinal waves are waves in which the motion of the individual particle of the medium is in a direction that is parallel to the direction of the energy transport. A longitudinal wave can be created in a slinky if the slinky is stretched out in a horizontal direction and the first rolls of the slinky are vibrated horizontally. In such a case, each individual coil of the medium is set into vibrational motion in directions parallel to the direction that the energy is transported. Sound waves in the air or any fluid medium are longitudinal waves because particles of the medium through which the sound is transported vibrate parallel to the direction that the sound waves move, regardless of the source of the sound wave, whether it is a vibrating string or the vibrating tines of a tuning fork. Sound waves travelling through air are always longitudinal waves. And the essential characteristic of a longitudinal wave that distinguish it from other types of wave is that the particles of the medium move in a direction parallel to the direction of the energy transport always. Now, let's talk about what are the characteristics of a sound wave. Sound travels in the form of a wave we have already established and learned. Waves are characterized by three basic quantities, that is frequency, speed and amplitude. Density and pressure varies when the sound waves moves in the medium. The density and pressure of the medium at a given point of time varies with distance above and below the average values for both. Compressions are the region where the particles are close together and are represented by the upper portion of the curve in the graph, and the peak represents the maximum compression. Hence, compressions are the region where pressure and density are very high. On the other hand, rarefactions are low pressure regions where the particles of the mediums are spread apart. The peak forms the crest and the valley is the trough of a wave. Two of the main characteristics of sound are pitch and loudness, which in turn are determined by the frequency and amplitude of the wave respectively. Therefore, to understand what is a pitch and loudness mean, we will first need to study the characteristics of wave. We will use the example of oscillation of a simple pendulum to explain the terms amplitude and frequency. Although a simple pendulum does not produce sound waves that we can hear, this example will help us to observe oscillations and to understand the terms involved. Now, what is a pendulum? A pendulum consists of a small ball, also called as the bob, attached to a string which is fixed at one point as shown in the figure. First, let's talk about wavelength. Now, wavelength is the length between two consecutive peaks, that is crest, or two consecutive valleys, that is trough of a wave. A wavelength is represented by Greek letter lambda. Louder sound has shorter wavelength and softer sound has longer wavelength. Now, SI unit of wavelength is meter. Now, the main characteristic, that is amplitude. If we pull the bob sideways and leave it, it will oscillate back and forth for some time and then comes to a stop. Now, the position where it comes to a stop is called as mean position. The maximum displacement of the bob from the mean position during an oscillation is called as amplitude of the oscillation. In other words, amplitude is the distance from normal to the crest or a trough. Amplitude is the energy of sound. Louder sound has greater amplitude whereas softer sound has shorter amplitude. Thus, louder or softer sound is determined by its amplitude. Since louder sound has greater energy, consequently greater amplitude, thus it travels to a longer distance. Softer sound has smaller energy, consequently shorter amplitude, thus it travels to a shorter distance. Now, amplitude is denoted by the letter A, that is capital letter A, and the SI unit of amplitude is meter. Time period. When the bob moves from one position and comes back to the same position, moving in the same direction. It is said to complete one oscillation. The time taken to complete one complete oscillation is called as the time period of the oscillation. It is measured in seconds. Now, the time period of sound wave is represented by letter T. Next is frequency. The number of sound waves produced in unit time is called as the frequency of sound waves. For example, a source of sound produces 20 sound waves in 1 second. Thus, we can say that the frequency is 20 Hz. Time taken to calculate the frequency is in seconds, and the frequency is denoted by the Greek letter nu. SI unit of frequency is Hertz. This name had been given after the German scientist, that is Heinrich Rudolf Hertz. Now, what is the relationship between time period and frequency? Now, if a one sound wave is produced by a source in t second, therefore in 1 second number of wave produced is equals to 1t. Since frequency is the rate of production of wave, therefore frequency is equal to 1 upon t. Frequency is equals to 1 upon time period. Therefore, frequency, that is mu, is equals to 1 upon t, where mu is the frequency and t is the time period. Thus, frequency is the reciprocal of the time period of the wave. This means the frequency is increased with decrease in the time and vice versa. Sound waves are produced due to and fro oscillations of particles in a medium. Higher the frequency of the vibrating object, the higher will be its pitch, amplitude and loudness. Now, the amplitude of the vibrating body producing the sound determines the loudness of the sound. If the amplitude is higher, the sound produced is also louder. Now, loudness of a sound depends on the amplitude of the vibration producing that sound. Greatness is the amplitude of the vibration, louder is the sound produced by it. Now, the loudness of a sound also depends on the quantity of air that is made to vibrate. Loudness of a sound is measured in decibel unit, that is dB. Pitch. The shrillness of a sound is called as pitch. The pitch of a sound depends upon its frequency. Higher the frequency of a sound, higher is its pitch. Quality. Now, the quality of a sound is also called as timbre. The quality of sound is the characteristics which enables us to distinguish between the sound produced by different sources. The more pleasant sound is said to be of a rich quality. A sound of single frequency, also called as pure sound, is called as tone. So, students, to conclude this lesson, we learned about different characteristics of sound. I hope you all enjoyed learning about sound, and if you have any more doubts, you can go to the following link.